Okay, students, this is a lesson over Chapter 9. We're talking about circles, the distance formula, the midpoint formula, a little bit about functional notation. If you're what I call a review person, this all seems to be review for you. Just work through it, and you'll be able to move on. If this has been a while since you've looked at this, please do like you've done the other lessons and work through this. So let me just explain it by some examples. I'm going to see if I could turn off my little video. Okay, so Chapter 9, or Lesson 9. That's whoop. Lesson 9. Okay. Well, in essence, it's about circles. First of all, what is a circle? It's a set of points that are equidistant from a given point on a plane. So my plane is this whiteboard, and the given distance here is all the same. Okay. Now, if these points are all the same distance from the center. Now, I could keep on doing these dots. It would end up forming what we call a circle. So notice those qualities, those properties of a circle. Let's do that again. All right, here's a circle. Now, here's the center. Remember, the segment that joins the 2 points that are on the circle, that line or segment that goes through the center, that is called the diameter. See the D right here? Okay, diameter. Now, what is the name of the segment that goes from the center to a point on the circle? Okay, that is radius. Okay, that would be a radius. Okay, piece, right? Okay, so that's the idea of a circle. And remember, this is a center. And the diameter is equal to twice the radius, or twice the length of the radius. So there's some basic information there. Now we could talk about the length between 2 points, or the distance between 2 points. And we can also talk about the special location in the middle. So a point in the middle, good name would be midpoint. Now we could also talk about the equation of a circle, and we'll talk about that in a moment as well. So one additional piece of information we need to be reminded of when we talk about this is the coordinate plane. Remember, you had an X and a Y, and you had points identified on the coordinate plane using coordinates. So we're going to take all of these ideas and put them together. The first thing that we need to do is we need to go back to this idea of the coordinate plane. Okay, these are called tick marks. That represents 1, 2, 3, 1, 2, and it goes negative going this way, it goes negative down this way. You have your x-axes and you have your y-axes. This is quadrant 1. So my question is, look, here's a point right here. Can you tell me the coordinates of that point? Well, it's 3 to the right and 2 up. In order to for us to make sure we understand that, we call that 3, 2. Point A is located at 3, 2. Now I'd like you to get used to saying that to yourself, 3, 2, because that language is very important in understanding your way and communicating your way around the coordinate plane, especially when we start talking about functions. So please keep that little tidbit in mind here. Okay, I'm going to erase that for a moment. Now the next thing I want to do is I want to talk about distance. Distance. So here's point A again, and here's point B. What's the distance between them? What is the length of this orange line? Well, it's pretty easy. I'll go from 1 to 3, so it's 2 units long. I could subtract its x-coordinates. Here the x-coordinate was 3. Here the x-coordinate is 1. And I could do that. That would be a way to find the distance between those 2 points. However, what if I had a point here, C? Well, I want to know what this length is right here, this purple. I feel a little bit like the Khan Academy guy with all the colors. But anyway, so what's the distance from C to A? Well, that's a good question. Now you may remember from our work in geometry from before, we have a right triangle. What is the relationship between A, B, and C? What is that? Well, we know that A squared plus B squared is equal to C squared. Okay, that is the Pythagorean theorem. So that's one maybe formula if you want to think about that you need to know. Alright, now let's see. I want to know if I made a right triangle here, I want to know what this length is. Well, you know, this coordinate right here is 3, 2, and this coordinate right here is 3, 0. I could just subtract the y's. So if I did that, I'd have a triangle that's 2 units here. Now how long is a triangle here? How long is a triangle this way? Well, this coordinate's 3, 0, and we know this is the origin, or 0, 0 right here. So just subtract the x-coordinates. 3 minus 0 is 3. Or we could have just counted 1, 2, 3. So 3. Now my question is, what is D? What is the length of that hypotenuse of that triangle? We could use this formula right here. So 2 squared plus 3 squared is equal to D squared. That's 4 plus 9, which is 13. 13 is equal to D squared. So D is going to be the square root of 13. Okay? Remember, on your radicals, reduce your radicals. If you can, if not, just leave it. So that is a way to find the distance of between 2 points on the coordinate plane. Now, what we're going to do is we're going to do a problem from your book. Now the problem from your book is actually a little more difficult, so we'll just get right to it. Let's call this point A and point B, or the coordinates, right? And I want to know what is the distance between those 2 points. You could imagine it. You could say, okay, -2, -5 is down here somewhere, -4, -3 down. You know, it's a little line segment like that. Well, we're going to use the distance formula. I will just give you the formula here and just ask you to remember how to use it. Don't get all upset about not knowing it right away. The formula goes like this: x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and that's all in the radical. To make it easy, just do this. This is x sub 1, y sub 1. This is x sub 2, y sub 2. This goes back to the idea of what a coordinate is all about. It's got an x and a y number or value. This is basically a plug and chug problem. There are shortcuts, but we're just going to do it like you've never done it before. So let's see. So I'm trying to plug in what I know. It's really like the Pythagorean theorem. So x sub 2 is -4 minus, that's this sign, x sub 1 is -2. And then I do the y's, -3 minus -5. Okay, Again, there are shortcuts here. What I would do is just, that's negative 4 plus 2. Isn't that negative 2? This is negative 3 plus 5, which is 2. Now we're going to have to square these numbers. So when I square negative 2, I get 4. When I square this number, I get 4. Remember, it's under the radical sign. Now, what is that? That is radical 8. And we know that radical 8 is radical 4 times radical 2, or 2 radical 2. So the answer to that problem is 2 radical 2 is the distance between those two ordered pairs. This is a problem right out of your textbook. So keep that in mind. All right. The next thing I need to do is I need to talk about midpoint. Midpoint's pretty easy, so let me just get to it. You're in I-20, you're at mile marker 2, you're a girlfriend or boyfriend's at mile marker 12, you got to meet in the middle, neath those old Georgia pines. Well, let's see how we're going to do this. What mile marker we're going to meet at in the middle? Well, let's see. There's 10 between them, so it would be 5 and 5, 5 and 5, and so that would have to be 7. Now, is there a shortcut for doing this? Well, yes, there is a shortcut for doing this. Just add the numbers and divide by 2. You're adding the markers. So 12 plus 2 is 4. 12 plus 2 is 14. 14 over 2 is 7. That does work. Will it work if you're on I-75? Well, that's a good question. 4 and 10. I want to know what the midpoint is. Okay. Again, there's 6 between them, so 3 and 3 you would think it would be 7. Okay. Could I use a formula? 4 plus 10 divided by 2. That's 14 over 2, or 7. Now, the way we're going to use this idea is to find the midpoint of two coordinates. Okay, this represents 2 points on the plane. It could be the endpoints of a circle. I don't know, but can you find the midpoint? Well, the way to do this is you're going to have an x coordinate and you're going to have a y coordinate. So just add the x's up together, divide by 2, add the y's up together, and divide by 2. So numerically, 2 plus 10 is 12. 12 over 2, that's going to give me the x coordinate. 6 and a negative 4 is 2. 2 over 2, that's going to give me the y coordinate, or 6 comma 1. Now that is actually pretty neat. This is the coordinate of the midpoint between these 2 points right here. You may not realize it, but your computer screen uses these ideas all of the time, and people who do navigation are working it all of the time. And if you ever Googled the directions and the distance to locations on a map, it's using these ideas. So keep that thought in mind. I want to take a note and talk about functional notation. Functional notation. So now here's an algebraic relationship. Y is equal to x squared. Alright, so let's just play this game. We'll call it the black box game. If I throw a number in for that box, what will I get back out? If I throw a 0 in, I will get back a 0. If I will throw in a 1, I will get back a 1 square, which is 1. If I throw in a 2, I will get a 2 square, which is 4. So notice there's a function to how I'm operating on those numbers. Now we call these x numbers the domain, and we call the y numbers the range. I could also write this in this notation. F of x is equal to x squared. F is really representing